In this video now, we are going to advance a bit on our discussion on algebraic fractions by looking at multiplication and division of fractions. So when we talk about fractions here, we're actually talking about the algebraic fractions. So we'll be looking at multiplication and division of these algebraic fractions. So we're looking at this example now. We are to simplify a squared minus 9 over a squared minus a times a squared minus 3a plus 2 over a squared plus a minus 6. So we have a squared minus 9 over a squared minus a times a squared minus 3a plus 2 over a squared plus a minus 6. So this is what we have. You are to simplify this. So the best way to handle this kind of situation is to start looking at factorizations, because here you see factorization is possible here, factorization is possible here. Of course, this is a quadratic expression. You check if it is factorizable. Here is also a quadratic expression. You check if it is also factorizable. Then if that happens now, you do the necessary factorizations and see if there are things that can cancel themselves out. And when that happens, what you have now is a simplified version of the original expression. So we look at the first fraction, and in particular the numerator. You see you have a squared minus 9. So you see that this could be a difference of two squares, in the sense that this a squared minus 9 is the same thing as a squared minus 3 squared, because 3 squared is equals to 9. So in that case, this is difference of two squares, which you can now write as a plus 3 times a minus 3. Okay? So now that's what you have. So you have that to be a plus 3 bracket a minus 3. Then at the denominator you have a squared minus a. So you see that a is common. So you can bring out the common factor a. Then you open up a bracket. So you have now a minus 1, which will be left inside the bracket. Then we move over to the second fraction. You still remember your multiplication sign. So here you try to factorize this. You have a squared minus 3a plus 2. You check if this could be factorized. Of course, we can factorize that. So if you do the factorization, you will see. So write this out clearly and see what the factorization will be. So you are looking at a squared minus 3a plus 2. So you see that this will be equals to a squared minus 2a minus a plus 2. So that's what you have. So here you have a, that is common, so you have a minus 2. Then the next one, you see that the minus 1 will be common. So here you have plus a minus 2. So you have a minus 1, a minus 2 as a factorization. So you have this to be a minus 2 times a minus 1. So that's what is going to be. Then similarly, if you look at the denominator here, a squared plus a minus 6, you see the same thing will happen. You agree with me that a squared plus a minus 6, if you want to factorize it, will now be equals to a squared plus 3a minus 2a minus 6. So that here you have a into a plus 3. Here you have minus 2 to have a plus 3. So that you have a plus 3 into a minus 2. So that's what you are going to have. So you have a plus 3 into a minus 2. So you see here now, you see like I said initially, few things can cancel out. So here, a minus 2 will cancel out a minus 2 here. This a plus 3 will cancel out the a plus 3 here. Here I have a minus 1. We cancel out this a minus 1. So what do you have now? At the end of the day, what is left? You now have a minus 3. That is, this is the only thing remaining. So you have a minus 3 over a. So that you can now say, therefore, that a squared minus 9 over a squared minus a times a squared minus 3a plus 2 over a squared plus a minus 6 is simply equals to, by simplification, a minus 3 over a. And that's what we have as a final answer. And you see actually that what we now have is simpler than the original expression.